No, this is kind of funny. The printer I had, actually, a friend of mine decided that I had to check out 3D printing. So I was into data and computers, and
Okay.
I was into homebrew computing and things like that. So
Yeah.
I've wire wrapped my own machines. So he gave me a 3D printer kit. It was the printer bot. And
Okay.
so
Yeah.
it was the plywood and zip tie version.
Nice.
So I was able to get a plywood zip tie 3D printer to make a metal part.
Hello there, Internet. My name is Adam Fosnot. I'm a mechanical engineer, and I have been working with 3D printers of all shapes and sizes for over 7 years. I've worked with machines from under $200 to over $200,000, and I have learned so much in the process. One thing I noticed is that a 3D printer tends to be judged on two extremes, one being a press release where everything is shiny and perfect, and the other being a YouTube review where a lot of times every product gets criticized. Another insight is that there tend to be two worlds in 3D printing, one being the industrial space and the other the hobby space, and those two worlds rarely talk to each other. This podcast breaks down those barriers to have a transparent, no BS conversation about the world of 3D printing and technology. I'm so happy to have you on board. Let's get started. To kick things off, could you just introduce yourself to the audience?
Sure. My name is Brad Woods. I'm the founder of the Virtual Foundry. This is a project I started as an invention in my basement in about 2014. In 2015/2016, I did a Kickstarter project that succeeded. We bought some industrial equipment, and we've been growing since then.
Gotcha. That's awesome. And the project itself on Kickstarter, could you give us a little bit more details about what it was?
Right. So when I started, actually, it's easier if I back up and say I started with 3D printing,
Okay.
printed some plastic parts, and almost immediately decided that in order for 3D printing to be relevant, we needed some better materials. And I had been working on different methods of fabricating metal objects that didn't require heat. So the whole concept of the virtual foundry actually predates the project by about 15 years.
Really?
I was initially using strategies with electrolysis, electroplating, things like that. And I did some fairly large scale pieces, like a sculpture that's probably 18 inches tall.
Okay.
And it's about 4 or 5 pounds of copper, but
Mm-hmm.
but it took weeks to create. Electrolysis is not a quick process. But I'd also been experimenting with powder metallurgy. So almost immediately as I became familiar with 3D printing, I saw the connection. I saw a way that I could combine powder metallurgy and additive manufacturing.
Gotcha. And I'm just thinking back to 2015. That was right around what I would consider like the start of the boom of 3D printing, where
Yeah,
like MakerBot and RepRap kind of started around the 2012 standpoint. And so this was really early. And here we are in 2021, and it seems like metal FDM is just finally starting to gain some traction.
yeah, it's been a very slow process getting people to accept that an FDM printer can make a metal object. Even in when I was starting out, people didn't want to believe it. I would show parts and things like that. And you couldn't have made it that way. That doesn't make sense. And slowly over time, it's gained more and more traction. Some of the bigger, more well-funded companies, namely Desktop Metal and Markforged, came online with big marketing budgets. And we don't consider them competitors. They're really after a different group of users. Our users tend to be researchers,
Okay.
hobbyists, makers, scientists, and they're just trying to make metal parts. So we don't really see them as competitors. But the nice thing they did is they helped legitimize the technology.
Okay.
So they had the marketing budget to put it out to the world as a good idea, and it was very helpful to us. And it introduced a lot of people to the concept.
Okay. So from the sounds of it, you've seen a lot more traction in the past few years just because of the public awareness. Is that right?
Yes.
Okay.
Sorry, there's somebody walking through my shop.
No worries.
Um, sorry, I lost my train of thought. But right, as time has passed, and the rate of acceleration is exponentiating at this point.
Okay.
So we've had more activity, as in like interactions with potential customers. It's happening at a rate. The rate of inquiry is many times higher than it was even a couple months ago.
Gotcha. I'm dying to know, what is your background? Are you an engineer? Do you have a machining background? Like, how did you find yourself in this place?
I am I think kind of a professional dabbler.
Okay.
Prior to this, my real job was I was a software architect for an insurance company.
Okay.
So managing big data systems and such. But even that, I don't have a degree in it or anything like that. I was self-taught in that. So I've been self-taught in a couple different disciplines, and this is the most interesting one. This is a lot of fun.
Okay, gotcha. That's great to hear. I've been dabbling in tons of different things since I was young, always taking apart different electronics and stuff. So I think we have some of that in common. While I'm on the topic, I glossed over a question that I always like to start with, which, can you tell us something about yourself, kind of outside of your company and what you do to work, just to help the audience get to know you a little better?
Boy, that's a tough one at this point.
It's a surprisingly tough question. Everybody struggles with it a little bit. So,
and at this point, as being an entrepreneur and starting up this project, it pretty much is both my hobby, my profession, and consumes an incredible amount of time. Okay. So I really don't do a lot outside of 3D printing and working with metal.
Fair enough, but I take it you enjoy what you do.
Absolutely.
Good.
And instead of becoming less interesting, it's actually getting more interesting.
Okay.
We keep different groups of people find different applications for the technology. And I mean, if we ran down a list of the different sort of disciplines that we're in, it's a little bit surprising. I mean, we do aerospace and automotive. Those things are pretty obvious, but we also have users in chemistry and biology. We have people printing like implantable medical devices. It's very, very early in that, but they're 3D printing titanium with an FDM printer with the intent of it being a spinal implant, for example.
Okay.
So it just keeps expanding.
That's exciting. If we rewind a little bit, what was the first material you started out with? I'm guessing during that Kickstarter campaign.
Right. Copper. So copper was kind of the easiest one to sourcing materials was an early challenge.
Okay.
And copper was just kind of the easiest one to source. And when I was starting out, I was able to source types of powder that were less than ideal.
Okay.
They worked, but it wasn't great. So the product had a tendency to be brittle, and it was difficult to work with. Over time, we've developed a much better supplier network. Like the copper alloys all come from, they would normally be going into the automotive industry for press and sinter type applications.
Okay.
So we just kind of hijack it from there. But yeah, as time has passed, we found better suppliers. We've come to understand what makes things brittle. And I get this question all the time: why is copper not brittle, but 316L is? And the best answer I can give people is there is no single answer to that question.
Okay.
It's everything. It's everything from particle shape, particle size, and the distribution of the particle size. And the factors just go on and on.
Okay. Interesting. And so do you make the filament in-house yourselves, or do you have specific formulas that then you have other people extrude for you? Hey there, it's Adam. If you're enjoying this video, could you go ahead and tap the like button? It's totally free for you, and through the magic of internet algorithms, it will help more people see the podcast. Thanks.
No, we do it all here.
Okay.
I don't think we could have outsourced this. The research phase was long and difficult. So during the research phase, I was able to buy a commercial extruder.
Okay.
So that part of it just comes from the plastics industry. We sort of we souped it up. I mean, it's highly modified. The screw that it uses is something that I made on the lathe behind me, and put a much bigger motor on it, things like that. When you're making filament, if the speed of the motor changes, the size of the filament changes. So it's all got to be very, very precise.
Mm-hmm. Okay. And then, so you started with copper, and then I'm guessing you fulfilled your Kickstarter orders, doing a ton of research at that time. The binding agents that you're using, is that something that's patented, or is that a trade secret, or what are you extruding with the different metal powders?
Right. We call the binder PLA compliant. It behaves like PLA as far as temperature and all of that goes.
Okay.
But simple PLA wouldn't work. It would be too brittle. So this is the development that I've done over the past few years, is tweaking the polymer to get to the most flexible and strongest filament to handle.
Okay.
So so it being filament is actually one of the key limiting factors.
Really?
And I've always had this fantasy that 3D printing would swing hard towards granules.
Okay.
Rather than using filament, but it's just not there. But we've gotten to the point, all the materials that we produce now are manageable.
Okay. And so you bring in the metal powder, you bring in the plastic granules, the pellets. What happens next? Right.
We combine them. I mean, it's that simple. It sounds so simple to say.
It does.
Never not. So, right, as raw materials, we have plastics coming in, and we have metal powders coming in. And the act of combining them into a filament that's strong enough to handle, but has enough metal in it to sinter well, is a very careful balance.
I'm sure. So do you make them into pellets first, like composite pellets, and then re-extrude into filament? Or do you just put it all in one hopper and make filament directly?
Right. So it depends on the material. Most often we will compound in one pass and then blend and then tune the metal content or plastic content, and then run that back through to make that into filament.
Okay. Interesting. When I think about the time frame that you started doing this research, and how much you've grown, you mentioned sourcing powders being a challenge early on. Was there any other like big challenge that sticks out in your mind when you were first getting started and getting successful parts?
Everything about it was a challenge. I mean, I don't think any part of this came easily.
Okay.
So all of our battles are hard fought wins. So it's been extremely challenging.
Yeah, I'm sure. When you first started, were you using a MakerBot, or were you using a different 3D printer? Because there wasn't a ton available at the time.
No, this is kind of funny. The printer I had, actually, a friend of mine decided that I had to check out 3D printing. So I was into data and computers, and I was into homebrew computing and things like that. So I've wire wrapped my own machines. So he gave me a 3D printer kit. It was the printer bot.
Okay.
So
Yeah.
it was the plywood and zip tie version.
Nice.
So I was able to get a plywood zip tie 3D printer to make a metal part.
That's incredible. So you made the filament, you started printing it on a printer bot. Um, Once the part is printed, how do you get from that to a dense metal part?
Right. So it's a heat process.
Okay.
So a couple things need to happen, and the first is obviously you have to remove the plastic.
Yes.
So this is one of the key features of the material, is that our polymer blend will go from a solid to a gas without passing through very much of a liquid phase.
Okay.
Um, so that's a key part of why it works. It off gases during the lower temperature phases of the sintering cycle. So that's the debinding phase, where you remove the polymers and then you go to a sintering phase. And in the sintering phase, quite simply, what you're doing is welding all those particles together.
Okay.
You never heat to the point where you're actually molten, but what will happen is if two particles are next to each other or nearly in contact, they'll start to exchange, exchange a few atoms here and there. And at sort of as the process, as it progresses, surface tension will pull it together.
Okay.
So it's actually surface tension that causes the whole part to shrink.
Okay.
And it's the shrinking that brings out the densification part of the process.
Okay. And so it sounds like you don't have a chemical debind in between those two steps.
Correct. We have a heat only. It sublimates on its way. So it's just kind of done in one step. You just put it in the kiln and hit go, and the polymers vaporize.
Yeah, but that's a much different and I think more advantageous approach to it compared to some of the bigger players that have that step in the middle.
Yeah, we think so. And I think part of the reason it works that way was my ignorance on the science of how other people were doing it at the time. I definitely took some of my research from metal injection molding.
Mm-hmm.
And most of that is done the way that you described. There's a chemical debind process and a multi-step debinding process. And some of them are, incredibly toxic and not attainable. So partly what's interesting about our process is low toxicity and simple availability. It's just heat.
Yeah. When you're putting a part into the debind process, the sintering process, how long does it take to go from your print putting it into pulling out hopefully a cooled metal part?
Right.
Or do you take them out when they're still hot? Do you have a question about 3D printing? If so, I would love to answer it. Feel free to leave any questions in the comments down below, or go to 3dprintauthority.com/forms to submit your question. Thanks.
You can. Early in the process, we would run them up to the sintering temperature and then pull them out of the kiln and quench them. So we were literally dropping metal flasks, red hot metal flasks, into water.
Okay.
So you could still do that, but most people don't want to handle a red hot crucible. So the timing, it actually varies by the material. It can vary by the size. It can vary by the shape. We have a user that commercially produces a heat exchanger. There's a case study on our website, and I think it's about 600 grams. It's over a half kilo.
Okay.
But his sintering process is over 24 hours.
Okay.
But we have other examples of people doing it much, much more quickly. Okay. So it varies is the answer.
Gotcha. But it sounds like 24 hours is kind of the high end.
That's definitely the high end.
Okay. And then what would be the low end that you've seen from your users?
Let me trying to think of a describe it. So, I mean, you want it to debind over a relatively long period of time. If you go too quickly, it'll simply boil and deform.
Okay.
So through the debind process, you want that to take, 4 hours, depending on how thick the walls are. There's other variables in there. So if it's a large, thick part and you're trying to remove the polymer from deep inside of it, you have to go slower.
Okay.
But I would say typical is probably an 8-hour sinter cycle, somewhere in there. That
Okay.
including the debind, from when you put it into the kiln until the kiln is done running. Not necessarily cool enough to open and handle, but the process is complete.
Okay. Gotcha. That's a pretty good range. And obviously it always depends. The size, the shape, the material, probably your infill density, all those different things.
All of it.
So while we're kind of on that topic, what types of parts do you think make the most sense for your filaments and this metal FDM process that you've been working with?
Right. And this is a common question. And I think the key misperception that most people have is people will say, oh, you can print metal. I'll print a trailer hitch for my car. So they're thinking in the wrong direction. But what works really well are parts that are generatively designed with Autodesk and Fusion 360.
Okay.
So we've done a little collaborating with them, and it just kind of works out that the generative design process produces a very organic shape, and that organic shape tends to work extremely well for the sintering process.
Okay. That is not an answer I expected. What is it about, if you know, what is it about the organic generative designs that work well with sintering?
I can't answer that today.
Okay.
give me another month and I might have a solid answer for you. But for now, I don't know. I can't exactly explain it.
I appreciate the honesty. I think I don't know is always a valid answer. But if you do figure out kind of a definitive answer, I would love to know, because generative design is such a cool topic, and I think we're going to continue to see it grow, especially as metal 3D printing grows.
Right. And this is part of sort of like what we preach to people about metal 3D printing is stop trying to think of it in terms of car parts. All of the parts on your car are meant to be manufactured by, or at least finished by a lathe or a milling machine or something like that.
Okay.
That's all a limitation that you no longer have. You don't have to deal with the limitations of a milling machine. You can completely think outside the box. So our general philosophy is that advances in metal additive manufacturing, the next important ones are going to come in more like the education department, and getting people to think about this a little bit differently. Think bigger.
Gotcha. Do you have any techniques that you use when talking to different customers to try to push them in that direction?
Pretty much the words that I just gave to you.
Okay.
I've given that talk to a lot of engineering departments, and I think people are starting to believe me, but it's taking a while.
Sure. I think I've brought it up with a lot of other people, or the topic has come up around education and kind of the mindset around how people design parts. It's come up a number of times. So I think it's interesting how you're bringing it up as one of the biggest challenges you're seeing from people too. I think it reinforces that theme for sure.
Yeah, absolutely. And it also, it changes the engineering part of it vastly, because rather than engineering a structural component, you're telling the software what the loads and what the specifications are. So it changes the skills that you need to make a part.
Definitely. Pivoting a little bit here, looking on your website, it looks like you offer a ton of materials compared with other metal printing companies.
Yes.
How have you decided what materials to pursue next? Like not only metals, but you also have ceramics and a carbon fiber material.
Yeah.
Tell me how you figure out what materials you want to make next.
The first ones that we did, so copper and bronze, I mean, copper is a kind of a no-brainer, and then you go to bronze for the same reason that humanity went to the Bronze Age.
Okay.
It's stronger. And from there, the next one we picked was stainless 316L. And
Okay.
I literally picked it because when I went out and did some reading, that was one that most people were talking about. So that was how we picked that product. As time has passed, most of the materials in our lineup are things that customers asked us to make.
Okay.
And they just kind of made sense. So we just kept them in our library. The next ones that are coming up, we're working on improving the engineered ceramics.
Okay.
Those need some development. That whole category is getting much more interesting. And alumina products, so aluminum oxides.
Mm-hmm.
It's another one. Being able to 3D print aluminum oxide parts is powerful. The one I'm working on today actually is borosilicate glass. So,
Really?
right. So people automatically assume that I'm talking about optically clear glass. So
Okay.
3D printing glass and 3D printing optically clear glass are two different things.
Right.
But we will have 3D printable Pyrex. We've prototyped it out. I've just been looking for a good supplier of raw materials, which literally just came in the door today. So,
oh, that's exciting.
yeah, so we'll have that in our store shortly.
Okay. Do all materials shrink during the sintering process? And do they vary between materials? Hey there, real quick. If you are enjoying this episode, could you do me a favor and subscribe wherever you might be watching or listening? It's totally free. It helps you not miss new episodes when they come out every single week. It tells the internet algorithms to help our content reach more people, and it would really make my day. I hope you think about it. Thanks.
Yes, they all shrink, and yes, they vary.
Okay.
And they essentially, like, the more material we can put into the filament, or maybe it's better to say the less plastic that we can put into the filament,
Okay.
the less the shrinkage will be. So, that, like I said, that's been part of our challenge in creating a material that sinters well, is getting enough material added into the metal plastic composite and still having it be strong enough to handle it. But the shrinkage is just kind of part of the deal. And this isn't in the powder metallurgy industry or disciplines. This isn't new. These things have been dealt with for several decades. So it's all manageable. You can scale up and anticipate the shrinkage and just build it into your part.
Okay. Interesting. So you can just make your model as you would normally, and then I'm guessing scale it up in your slicer.
Yep.
And then print and sinter.
Correct. And you tend to get a little bit more shrinkage in the z-axis just from gravity pulling on it a little bit harder. So
okay.
we tell people to print about 120% in X and Y and 125% in Z.
Okay. Interesting. And that's because of gravity, not because of differences in layer adhesion from what you understand?
We don't think so, but
okay.
What I understand is a crucial point there. And this is one of the topics that we're working on. We have a guest in the shop this week, and this is one of our topics, dealing with differences in the axial strength of the parts.
Okay.
Sintered well, I mean, they should be built on the metal grain structure, but yeah, it's a big topic.
Okay. So going off of that, is it fair to say that there are some differences depending on how the part sinters in X, Y, and Z?
Yes,
Okay.
there can be. Like I said, it tends to be very uniform in X and Y and just a little bit extra in the Z.
Okay.
And it doesn't matter if you take the part and turn it, it will still shrink in the Z.
Gotcha. Okay. See, part of how my brain is working through this is thinking about our printers and how they print at an angle. And I'm just so curious how something like that would sinter
That would be interesting.
with angled slices.
Yeah. Well, could I ask you a question? So
Yeah, of course.
how do you slice for that style of printer?
It used to be really difficult.
Okay.
There used to be like a plugin that a guy named Bill Steele wrote, and you had to like punch in your angle and then use a post-processing script. Now it's an idea maker. So idea maker is Raise 3D's slicing software. You just like go to the advanced tab, hit belt printer, hit angle, and set whatever angle you're printing at. Super easy. So we have idea maker profiles for different materials and for the printer that people can just load in and start printing.
I will be checking it out at some point.
Yeah, I do YouTube videos on different aspects, really just to help the customers with things like setting it up an idea maker, calibrating your printer, all sorts of stuff. So feel free to check it out later today if you feel like it. But
I will. I mean, that must raise some discussion on overhang. I mean, because it doesn't your overhang it's at a slightly different angle now.
yes, all the rules are completely different. And I have an article on our website about how to orient and slice models. So I would recommend that also.
I will take a look at it. One of the things that I think that needs to happen in FDM 3D printing is non-planar slicing.
Gotcha.
I think we got to get past that. They're 3D printers, but we're only doing 2 dimensions at a time. So.
Yes. Very true. I think we'll see it eventually, whether it's non-planar or whether it's adding 3 or 4 or 5 axes. I think it's something we can look forward to. But to your point, a lot like how what you're doing with all these different metals, I think it's very early for some of those things. It's just not common yet.
Right. Yeah, it is. And with the materials that we put out there early on, just to prove viability, we published, specific sintering instructions for copper. I mean, and we have general instructions for all of them now. But as we add new materials, it's not practical for us to develop a sintering cycle for all of these new materials. So we simply acknowledge that we're not going to be able to do that, but we know that it can be done. So we put them out there, and people have been very good about sharing their research.
Gotcha. That's really cool how you can kind of get feedback from people and collaborate with your customers on sintering processes. From what I understand, you guys offer, and I don't mean this in a bad way, but just filament. Is that right?
That's correct. We're changing a little bit. We have a line of kilns that we sell.
Okay.
And we're likely going to put a printer out there also. So
okay,
the material will work in nearly any FDM printer. I mean, that will let you use a third-party product. I lost my train of thought. But everybody's first question is, what printer do I buy? So we decided to just put together a printer and say, here, use this. And so it's kind of like we're hot rodding some of the Ender machines with Big Tree Tech makes some really nice add-ons. So we're just kind of souping them up and making them into the printer that I would like to use. And then we'll make those available to our users.
Okay, cool. I have so many thoughts on the Ender 3 because there are so many clones now, and there's so many different add-ons, and it's just become like the most economical small platform printer out there. I think the impact that it's had on hobbyists and education and all this other stuff is incredible. But I digress. So you offer filaments today. You do build kilns, or are you distributing a kiln that you know works really well with your filaments?
Right. These were custom developed by Paragon. Paragon is probably one of the bigger kiln manufacturers in the United States. So it's a machine that they tailored to our needs.
Gotcha. Okay. That's good to hear. So it wasn't just like an off-the-shelf kiln for glass or something else, but it was kind of created for metal FDM.
Yes.
Okay. When you're looking at this overall process, how big of parts can people expect to make, or how big of parts have you made? Do you want to be a guest on this podcast? If so, go to 3dprintauthority.com/forms to apply. Thanks.
Probably, let's see. The biggest part that someone makes regularly is the heat exchanger product that I was talking about.
Okay.
And I actually can't exactly remember how big it is. The largest piece that we've done in-house, and this is just to do something big to see how it would work, is a sculpture about 8 inches tall that weighs 6.5 pounds.
Okay.
Someone just handed it to me.
Oh, nice.
This thing, it's like, I don't know how to illustrate how incredibly heavy it is, but
okay. We've confirmed that it's real metal. It is heavy. I'll take your word for it.
Chunk of metal. So, right, that's 6 pounds of copper. But getting that big, I mean, it has its own challenges. It's going to shrink. You got to factor that in. So,
okay,
we try to be very careful. I don't want to create the expectation that someone's going to buy our material and be making metal parts tomorrow.
Okay.
Problems can be solved, but there's a little more to it than that.
When you say there's a little more to it, what are some of the common things that people experience when they're first starting with a metal FDM process?
Right. Most of these are the same ones that you encounter. Like, once you get a 3D printer and you start working with it and you realize that, wait a minute, this is more than just buying a thing.
Right.
And making a part. There's just more. There's more steps. You don't just hit go. So the journey from 3D printing plastic to 3D printing metal is kind of similar to the one where you go from not 3D printing to being able to 3D print.
Okay.
The challenges are very simple.
Okay. So is it challenges around like printer temperature, retraction speeds, those sorts of things?
Right. What printing profile settings have been a huge topic, and what we've recommended to everyone, and we have, like, if you own an Ultimaker and you use Cura, we have profiles out there that are available.
Okay.
But you only see them if you're using that exact configuration. So
Gotcha.
Our general instructions to people, and what we put on our website, is pick the generic PLA profile in Cura, change the temperature to 235, so raise it, and change the extrusion flow rate to 140.
Okay.
So the first problem people have is that the printers aren't moving enough material through the print head.
Okay.
So if you just exaggerate it, and a 40% exaggeration sounds like a lot, and another one, we're not exactly sure why, but it comes out right about even. So with those two mods to the Cura generic profile, you'll be printing pretty quickly.
Okay. That's encouraging. Those are two settings that I know right where they are.
Right.
I found that when printing with carbon fiber filament, also, you have to increase the flow rate, or you have to print with thicker layers. Like, you have to keep the material moving through there.
Right. I have a theory on why it's happening, but I'm not exactly sure how to prove it. But
Okay.
the material, as it's passing through the print head, I believe that the viscosity is non-Newtonian. So as
Okay.
you try to push it harder, it actually pushes back slightly harder. So the difference, it isn't perfectly linear. But excuse me, but a flow rate of 140% seems to overcome the problem.
Gotcha. That is not an explanation that I have ever considered, but I can imagine it now that you bring it up. Where it's solid particles suspended in a liquid once the plastic is molten in the hot end and it compresses. I really like that explanation. It makes sense to me. I'm not sure how we would prove it either.
I don't think I can prove it.
As you've gone through this journey for 2015, 6 years roughly, has anything been easier than you expected? I know we've talked a lot about the challenges of early research and starting all these different materials, but has anything surprised you that was easier?
The one thing I think would be how receptive people have been. I mean,
Okay.
we've had a lot of, I think early on, we kind of went after the wrong people, and we attracted a lot of artists that had never 3D printed before, and they bought our material and became very frustrated.
Okay.
So the place that we found the most comfortable home is with research labs and solving problems that there just was no good solution to prior to this or these materials coming along.
Okay.
I think there are 17 national labs in the United States. Of that, about 12 of them are active customers.
Okay.
So there are applications in nuclear energy is a recurring theme for us.
Really?
We make a material that is roughly as dense as lead, not quite, but it's close. So it's tungsten, but it's a 3D printable, non-toxic lead replacement.
Okay.
So this has been an interesting project for us, and the applications are things like munitions, demolition, projectiles. Then on the other side, vibration dampening, X-ray shielding, which is actually what we made it for, but
Okay.
keep finding other uses for it.
Okay. And then why does 3D printing make sense? If you look at just the tungsten nuclear energy example, why does it make sense for them over traditional machining or casting? From your understanding, obviously they're a customer and they probably aren't sharing everything, and it's a research institution. Right. So
yeah, usually when we ask people, and mostly they say no, but we ask them anyway. Just we'll share what they're up to, and some do, but it goes back to what I said earlier. It's a new way of solving the problem. Mm-hmm. It isn't. We don't consider it a great solution for creating a new heavy-duty hydraulic 10,000 psi type pressure vessel or something like that. But it's a way of forming materials into shapes that there was simply no way to do it before. And now that you can do it with our materials, it can be not just plastic, but metals and glass and ceramic. Things just get more and more interesting.
Yeah. Okay. So what I picked up there is it's a new way of forming the material. And so for challenging materials, it gives you a new way to shape it. I can think of like really hard materials like titanium, right? It's awful to machine. You don't want to touch that if you don't have to. And so 3D printing gives you another avenue to that end part that you're going for.
Right. And there's some examples, and these are very, very specific applications, but where materials won't tolerate heat, or if you raise the temperature of a material, it becomes a different material. And then this is
Okay.
the ceramic metals and the transition metals, some of the things in there. This is where people are finding you can fabricate something and sinter it, whereas if you were to try to cast it, it would destroy it. Or if you
Okay.
tried to even weld it, it would destroy it. But it will tolerate the temperatures that it needs to sinter into a solid.
Gotcha. Very interesting. My imagination is moving a lot, thinking about all these different materials and like very specific kind of high-end applications outside of just people wanting to print car parts. I like to wrap up with some higher level questions. So the first one that I like to ask is, what is one thing that you don't like about 3D printing? Just like as a whole, maybe you think it's too slow. Maybe you think we need more materials. Maybe you wish all 3D printers weren't black in color. Just anything at all that you don't like.
I wish that someone would come up with a really, really good pellet-based 3D printer.
Okay.
let's be done with filament. I don't expect that to happen. And I'm also not sure why this has been such an engineering challenge, but to the best of my knowledge, nobody has a really great pellet-based 3D printer.
Gotcha. That is also something that I would love. If anyone is out there listening and wants to make one of these, I've seen it for really, really big stuff.
Yeah, me too.
But I haven't seen it for just like a desktop machine, but it uses pellets instead.
Right. How hard can it be?
I share that frustration. Actually, I cleaned up my desk earlier today, but I have been prototyping a very compact pellet extruder that you could put on any machine. So I'm working on it.
Right.
But then I have to juggle my different projects and figure out what makes sense as like the next product. So we'll see if I ever get around to it. If I think I have something good, I'll shoot you a message and see if you want to test one for sure. Because I share this frustration with you.
I guess I've declared this enough publicly that we've gotten a couple people that want us to try out their pellet.
Really?
Pellet. So it happens.
Okay, I love that. And then another question, when you look at 3D printing as a whole, outside of your company and your products, what's one thing that you've kind of seen that you're really excited about, whether this is a particular trend, a special technology, or something you want to see more of in the industry?
Oh, it's going to be generative design.
Okay.
Far and away.
And why generative design? Why does that stand out to you so much?
For one, the parts look cool.
They do. They look like they're from the future.
Right. The organic shapes, it's kind of incredible. But also, it sort of de-skills a lot of engineering tasks. So rather than designing an entire part, you're handing it a set of parameters and a problem that you want to solve, and it hands a solution back to you.
Gotcha. I do really like that aspect of it, and I didn't think of it in terms of de-skilling the operation, where in theory it makes 3D printing and manufacturing more accessible to people that don't have that engineering background, which is a really cool aspect.
You don't have to master CAD.
Exactly. Exactly. Thank you so much for taking the time to join me. Before we sign off, where can people find you? Where can they learn more about Virtual Foundry? And if there's any specific follow-up calls to action you'd like them to take, now's your chance.
Right. Yeah, go check out our website, thevirtualfoundry.com. You can also just Google the same. We've had a lot of really nice articles written about us, and people have been generally very supportive, especially in the media. So we've had the help of some really great people. We also were beginning to promote a forum, discourse.thevirtualfoundry.com, and the intent is to just give a little bit more access to the people here and get questions answered more quickly. The way it's working right now, we sit down every day and we go through and answer, a half dozen emails with specific questions. So we're trying to shift some of that over into the public forums. Let's just get it out there and talk about it.
Gotcha. Very cool. I think that's a really great way, because then people like me who are just looking for information on a topic can go right to the forum and learn more about the process. So thank you again, and I'll look forward to connecting in the future.
All right. Thank you.
Thank you so much for taking the time to listen to my chat with Brad from the Virtual Foundry. I will make sure to link to their website in the description of this episode. I have said it before, and I will say it again. The metal 3D printing space right now, I think, is very interesting. I think it's growing at a rapid pace, and people are coming out with so many different takes on metal 3D printing, different methods of making objects, and I think it's an exciting time to be a part of the industry. I think that their approach is a little less refined than some of the bigger players, Desktop Metal and Markforged being the obvious examples. But I don't think that's necessarily a bad thing. I think by being a little less, it's a little less of an ecosystem, right? So they have almost more of a DIY open source type of methodology, which I think will really appeal to researchers and education, where some more well-defined but also more locked down systems like those from Desktop Metal and Markforged in terms of how the parts are processed wouldn't appeal to those sectors as much, but they would appeal more to small businesses and machine shops. So for me, it's interesting. I think it's cool that there's kind of multiple different customer bases potentially for those products, and the reasoning behind them doing what they're doing. If you haven't already, please subscribe to 3D Print Authority wherever you might be watching or listening. It helps us grow and spread more transparent, no BS information about the world of 3D printing technology so that everybody can learn and grow and do great things. Make sure to check out the Virtual Foundry, as I mentioned, if you are interested at all in metal FDM 3D printing. Thank you again for watching. Until next time, happy printing.